here to give you an introduction into the Session Smart routing technology and some multiple product demonstrations. So first we have Reed Stidholf, followed by product expert Adam Morris.
All right. Well, thanks so much, Kenny and Kevin, for the kickoff. SD-WAN. I'm a relative youngster to Juniper. This is my first kind of summit customer event as part of Juniper, and you know, I'm not too sure whether or not Juniper has hosted SD-WAN boot camps in the past, but I am sure that this is the first one that is Session Smart. So I wanted to do my part in kicking off this boot camp by really, you know, introducing what Session Smart is, you know, what it means, where it came from, and why is it here at Juniper. And, you know, Kenny and Kevin know I enjoy talking about this journey of Session Smart technology and secure vector routing because, you know, I was lucky enough to have a front row seat for most of it. And I love telling a bit of my story and my unique perspective on how it all unfolded. So let me advance. Yeah, so to start with, you know, I want to kind of just rewind the clock a little bit, all the way back to 2015. Here, what you see here is a picture that I snapped as I first set foot into this barely furnished office space right off of Route 128 in Boston, Massachusetts. And now I'm from Seattle. So out here in the Pacific Northwest, and I had flown all the way across the country to Boston, and this was my first day on the job. And so the company here was founded in 2014, like it says, really just a handful of months before this picture was taken and before my first day. Now, what you see here is essentially the entire company at that time busily writing code for what they hoped would someday become a product that would change networking. And, you know, one of the lasting impressions for me that day as I walked, you know, right down that center aisle past all these engineers was back in the back at a desk right alongside everyone else was Patrick Malampy and Andy Ori, two tech giants in real-time IP networking. You know, they are, some of you may have heard that name. You know, they are widely credited for having invented the modern session border controller and you know, really pioneered the entire market for SBCs. So, you know, what was lasting about that impression for me was that the last time I had seen these two, they were like royalty. I mean, they were at Oracle, where their company had recently been acquired by Big Red, and you know, they were being whisked around the world to conferences and marketing events as luminaries of the VoIP industry, you know, highlighting keynotes and surrounded by armies of admins and all that good stuff. And you know, yet here they were fully engaged in this tiny new startup, sleeves rolled up, doing work, you know, real work. I think, as I recall, Patrick was signing checks for business expenses, and you know, Andy was kind of buzzing around the desk, sometimes deep in thought, other times, you know, stopping to exclaim some, you know, profound thought he was having. But you know, in spite of the drab decor, there was an absolute buzz and energy about the place, and they were all talking about sessions, and they were all talking about a problem with the way networks were being misaligned with where businesses were needing to go. Now, back at that time, SD-WAN really wasn't a thing yet. You know, SDN and NFV were kind of the hot market lingo that marketeers were talking about, and you know, those technologies were kind of climbing the peak of inflated expectations in the proverbial hype cycle. And you know, arguably the tools of software and software defined were still kind of looking for a useful marketplace to land with broad acceptance and utility. You know, of course, in hindsight, we know that a few years later, that place would ultimately turn out to be the WAN, and but not a lot of people were talking about that at the time. So, you know, many of the team that you see here had come from a background in IP telephony. And as such, they really looked at networking through a slightly different lens. For instance, in an IP voice and video application, they operate inherently on the notion of a session. In that world, I pick up a phone and I initiate a call to you, and there's a signaled session that gets established, and there's a directionality to it from me to you. And then based on that, there's a symmetry in the conversation that progresses and we exchange information. So, this approach to sessions where there is a signaled exchange that establishes the intent and the disposition of the network towards the session were some of the formational concepts, as you'll see. But again, at that time, while networking was certainly seeing some notable changes around the industry that it hadn't seen for a very long time, thanks to being, reinvigorated by the powers of software and software defined. The IP routed networks that everyone was building upon were largely being built and operated the same way they had for the past 20 years. Now, the routed networks were sort of born out of, if we go even further back, they were born out of a theory that looks like what you see here. Is the internet boomed in the 90s, conventional wisdom was to really keep the network stateless, leave all the security to the endpoints, and just keep it fast and keep it simple. Now, this was for good reason, mind you. In the early days when RFC 1771 was being drafted by the long-bearded wizards at the IETF, it was all the internet could do to keep up with booming demand for networks. And based on the technology today, just making it bigger and faster was absolutely the most important thing to focus on. So routers started out simple. Now, if that was the theory, fast forward 20 plus years to this team working on the Session Smart router, and the reality in 2014 looked much more like this. As networks grew, high value targets such as financial institutions, governments, businesses began to transact on the networks, and turns out security was needed in the network. Security, having this open any-to-any network was not secure enough, and so firewalls were added on top of that routed network. To help as demand grew and load grew, to help intelligently distribute that load and scale applications, load balancers and other stateful devices got piled on top. And then of course, because the networks, the routers in the network weren't smart enough to take packets to places where they needed to go, tunnels and overlays proliferated. So the networks were envisioned to be simple and stateless, but in reality, they had become anything but that. State was everywhere in the network, and complexity was the result of it. People were spending $1 on a routed network that would be open and connect everything, then $3 to pile boxes on top to stop packets from going places they shouldn't go, or get packets to go places where the router couldn't take them. So, for the majority of the industry that was sort of wielding the power of software and software defined at that time, they were busily focused on taking the same approaches and architectures that they had done in hardware and recreating them in software, which is really just compounding the problem of fragility and complexity under the surface that was festering. And truthfully, about the only medicine that was being applied to this malady was throwing more orchestration, more automation at it. This really is the definition of technical debt, and networks everywhere and consumers of networks were just accumulating it. So back to the team in 2014, they said, what's going on out there is just not enough. If all you did was take the same things that you did in hardware and do them in software, you were doing it wrong. So the promise of software defined and unlocking new innovations in networking to power the next generation of networks just could never be realized the way things were going. And, the crash into the trough of disillusionment in that hype cycle for SDN was all but assured. So that was the mindset. That was the mindset and some of the formational thinking amongst that small team that was conceiving of and building the first iterations of the Session Smart router. So, what they set out to do first and foremost was make a router, and make a router that was smart. So they wanted to have a few key things that they felt a smart router just had to have. First of all, it had to be software. It had to make the best possible use of software and the powers of software defined. There's that famous saying, software is eating the world, and it's for good reason. No hardware could compare to the rapid innovation cycles that was happening for the platforms that were ultimately powering software, and the superior economics of software. So, from the powers that, or from the platforms that power software, from small to large to cloud to data center, and the economics of all of them, it had to be leveraged well by this technology. So next, it had to operate based on sessions. Like Kevin was mentioning, in the journey from client to cloud, sessions are the thread that connect users to applications. So no doubt, session state, as we define it, and as the Session Smart Router defines it, was already all over the network, but it was being piled on in uncoordinated middle boxes, disjointed from the routers. And a certain amount of that network state, the feeling was that a certain amount of that network state needed to be democratized into the routing plane and just be everywhere in a manner that is highly coordinated and controlled across all the routing nodes in a network. So, things like zero trust could not be easily managed in traditional box-centric ways at security bottlenecks. This session awareness needed to be tightly coordinated by global policy and signaled throughout. So also, the way the network was designed, how it was operated, had to orient around services. Kevin mentioned this, but services, after all, networks exist to deliver services, and without services, what's the point of a network? It had to revolve around services and not IPs and ports and prefixes and the other network-centric constructs that traditional routers operate based on. So from the data model to the forwarding plane, named services that were named and ordained onto the network needed to be at the heart of it. And finally, security had to be baked in, not painted on with perimeters and standalone security devices, but native and zero trust and at every single router hop along the way. So the whole idea behind Session Smart was to build smart routers that could understand services and applications and natively route them to where they needed to go in the topology using sessions without sticking them into tunnels that compromise on performance and on user experience. So these routers, the design was that they could be placed all over in the network, integrating with traditional routers, speaking their language like BGP and OSPF, and one could begin to parachute them into strategic points in the routing plane, like branches, edges, clouds, data centers, really to begin the journey of making their network more intelligent. And of course, a key ingredient to this is something we call secure vector routing. Now, I don't want to steal Tim Ziemer's thunder too much, but I know he'll be diving deeper into that one later. Just a heads up, he may be the only head of sales you've ever seen do an accurate packet walk and actually know what they were talking about. So, so more on secure vector routing later. I know Tim's going to walk us through that, but it is certainly one of the foundational technologies when we say tunnel free and how we forward these across the routing plane without expensive performance hampering tunnels. Secure vector routing is really one of those secret sauces. But this group at 128 Technology ultimately spent the past 6 to 7 years taking this router to market, proving and improving the technology in some of the largest SD-WANs on the planet. And of course, late last year, they joined forces with Juniper, who turns out was on the exact same mission as them with the AI-driven enterprise. That mission being to make networks an accelerant and a catalyst instead of a bottleneck for enterprises that were undergoing digital transformation through some real innovations in networking, not incrementalism. And these innovations that we're going to put experience first. So that really brings us to today and our Session Smart SD-WAN bootcamp. Now, by way of kind of getting into the product, let's start with some of the bullets on that big green slide. Let's start with software and take a quick look at the product. The Session Smart routers are software based, so they run on standard x86 compute platforms today. Now, they leverage a kernel, what's known as a kernel bypass technology, namely DPDK. Many of you have probably heard of it. But it really streamlines standard, off-the-shelf components of the NIC, CPU, and memory to really achieve hardware-like performance for latency and throughput. So there's a lot of optimizations built into the software leveraging this, not just on smaller, server platforms in branch and edge and data center, but also in the clouds as cloud environments as well. So while the software runs on commodity white box platforms, it has a versatile set of certified platforms that are rigorously and continuously tested in our automated test environments to really be able to give the highest levels of assurance for functionality, performance, and support. And so we're going to touch a little bit more about that certification program here in a moment. But no doubt the software scales. And it scales in all directions. It scales up very, very high to some of the highest throughput in SD-WAN applications out there. No doubt it is a key differentiator how we are able to scale at the very, very high end thanks to secure vector routing and tunnel free versus traditional tunnels, but also down on the very, very small end, going to very low cost devices, embedding within container environments and hypervisors and things like that. So, scaling goes in both directions, of course. And, being software and software defined, it really has a rich set of secure and open APIs, really making it ready for automation using the latest and greatest in automation tooling of the day. Many of our customers enjoy the benefits of the APIs, and I know Adam in a moment is going to walk us through some of the some of the user interfaces. But just know everything that you see in these user interfaces, you can almost consider them reference applications for the underlying API that really powers the platform. So getting kind of to that diagram there over on the left, the software is developed and distributed in a single packaged form that is initialized to one of two current functions. That software can be initialized to become a conductor, or it can be initialized to become a router. And of course, router is a tightly integrated forwarding plane, control plane, and conductor provides that management plane and automation for the deployment. And again, Adam's going to touch on that in more details here shortly. But looking at this more from a topology perspective, conductors, one slide too many. Conductors are typically deployed centrally in the networks, integrating with other management plane tools and operation systems. Like I mentioned, they kind of centralize a lot of troubleshooting tools, operational tools, management tools into one easy to manage place. And then under the management of conductors, the routers are deployed out to the far reaches of the network. And again, we'll look at this in more detail in the demo here shortly. So getting to one of the other key bullets on that green slide is security. Now, security is at the heart of the Session Smart router, and it has all the functionality and all the functions of a typical network firewall baked right into this router. Now, security is no doubt a really large topic, and actually it's going to be covered in more depth later when Kate and Prashant talk about SASE and the security architecture. So I'm not going to go too deep into this one, but just to kind of dip our toes in a little bit with the SSR fabric, traditional firewall and network security policies are defined globally for your administration domain, and they're enforced uniformly at every Session Smart router along the path. This is in contrast to traditional perimeter-based security, or where you have these box-centric rules that are defined, in silos at security choke points. So the product, as you see, has achieved many different certifications for security, some of which you see listed here, because it is, like Kevin was mentioning, deployed in some of the most secure networks that really require these sorts of things, these sorts of certifications. So let's talk about platforms for a second. How this software gets, from our engineers' laptops and coding terminals to into devices on your network. Of course, software needs some platform to run on. So, like I mentioned, there's, it runs on standard x86. But we like to highlight 3 key go-to-market options that are preferred by most of our customers. Now, kind of working left to right on this slide, probably the most preferred is a meet in the market model with a partner of ours called Arrow, who functions as effectively a virtual OEM for Juniper. Now, Arrow does a ton in the supply chain with providing these platforms, things like coordinating inventory forecasts, staging, software imaging, helping out with ZTP, and providing worldwide fulfillment and RMA services. So Arrow is a really great option if you are looking for a partner that can really do it all from a deployment and rollout perspective, up to and including boots on the ground deployment services for things like remote branches. So a great option there if you just kind of want that appliance-like experience. Now, we also support what we call a direct to white box vendor option, or ODM white box option. So this is really where you can take our list of certified plus devices, and you can kind of look at that menu and that portfolio and go directly to those vendors. Some of them which you see there: Silicom, Lanner, Lenovo, Dell, and they'll take your order direct for those platforms. Of course, when you go that route, they typically don't offer something like an Arrow does, like software installation and provisioning and stuff like that. But that's not to say that that isn't offered in some forms. We have a host of managed service provider partners, which I know Mark's going to talk and others are going to talk about later. But often some people still realize the benefits of this ODM model, but kind of going through service providers and managed service providers, like you see kind of in that middle box. And then actually, long before the Session Smart router became a part of Juniper, Session Smart routers were being run on Juniper NFX platforms, and so the Session Smart router is available and supported on a Juniper box, a Juniper Universal CPE. Now, this is a preferred deployment option through service providers and MSPs. That kind of want that universal CPE experience, and the SSR operates as a virtual node within that environment. So, looking a little bit more at the certified plus platforms, I would encourage you go to some of our documentation. I think maybe once I'm done talking, I'll dig up a link to where some of that information lives. But you can see all of these different Certified Plus platforms. You can see what all goes into Certified Plus. Like I mentioned, all these platforms that are Certified Plus means they go through nightly tests, rigorous tests, and so you have the highest level of assurances for performance, for operation, for functionality possible when you go with some of these Certified Plus platforms. But you know, when we certify these platforms, we specify the exact bill of materials in them. We lock down the BIOS, the BIOS versions. We help manage product lifecycle management in them. So if you know, if parts ever become end of life on these platforms, you know, we update them and refresh the parts in them, and then, like I mentioned, they go through our nightly software testing. So, you know, kind of going from the small end, the typical branch devices, you see a couple there from Lanner and Silicom, you know, that are capable of you know, up to 2 gigabits per second in terms of throughput, really going line rate on those devices. And then the next number you see there is actually encrypted performance. You know, that's one thing I didn't touch a lot on, but you know, certainly the platform, because of the efficiency of secure vector routing, we are able to use those crypto resources, you know, very, very judiciously, and we scale higher than anyone else in the market when it comes to encryption performance. So, you know, kind of the number on the right shows some of the higher end encryption performance if you were encrypting 100% of the traffic, which isn't always required, rarely necessary actually. And then on the right, you get some of the unencrypted, just routed throughput numbers. Of course, moving up there's a handful of Lenovo builds that you know, that really start to get you up in the 10 plus, you know, nearing 100 gigabit per second range. And then in addition to this, like I mentioned, cloud platforms like Azure and EC2 were available on those marketplaces to kind of put Session Smart routers at those locations as well. So that's platforms. And, you know, at this point, we've talked through kind of the origin story of Session Smart and how it came to be powering SD-WANs. So next, we're going to take a look at the product in action. What we're going to look at here upcoming is the conductor. And, you know, conductor is typically, like I mentioned, it's deployed in the management plane. So, you know, your operations folks are going to need to get to it to operate day to day. It hosts troubleshooting tools and things like that. And again, it kind of provides a gateway, an API gateway to everything else in the network, to the configuration, to stats and analytics on all the routers. So typically it's deployed, you know, sometimes in data centers where it can be integrated with back office systems for automation and control. You know, increasingly the cloud is a popular place to deploy conductors, because that, you know, ends up inevitably being a central point to a lot of these WAN networks, and it can sort of manage from that point in the cloud. Yeah, great question. And you know, up to now, we've kind of talked a lot about the, you know, really the theory and the history of the Session Smart router. But this being a boot camp, the first demo that we wanted to give is one that would kind of put you behind the wheel of the product, and then give you a sense for it operationally. So there's really no better person to do that than my good friend Adam Morris, who heads up North American sales engineering for Juniper and the SSR, and is really a subject matter expert in Session Smart SD-WAN. So we're going to go straight to Adam, taking us through a demo that was recorded. This is a recorded demo. Yeah, let me go ahead and roll the demo, and then we'll kick it over to Adam.
The purpose of this demonstration is to provide a high-level platform overview and give you a sense of what it is like to operate a Session Smart network. As we hop into our Juniper Session Smart router deployment, let me take a moment to introduce a few components of the architecture we'll be looking at. In a typical deployment, Session Smart routers are distributed across the network topology, client to cloud, participating with other traditional routers to form the WAN. The SSRs function as a tightly integrated control plane and forwarding plane element and are orchestrated by a management element called the conductor. The conductor has several key functions. It provides a single pane of glass for administration using graphical and command line interfaces. It hosts a centralized API for all devices, which integrates easily into third-party platforms for automation and management purposes. This provides access to the thousands and thousands of rich analytics and metrics. Also, it delivers config and lifecycle management for all the SSRs. Let's log in and take a look. Users can be authenticated based on locally provisioned accounts or from a central authentication provider such as LDAP or Active Directory. Upon login, you are first greeted with a dashboard page. This page is a launchpad to all different areas of the product deployment. In the upper panel is an indication of the quantities and health of all SSRs under management. To the right of that, you get an alarm summary. Next, the configuration overview shows if there are any active changes that require attention. Finally, in the upper right section is the overall health of the conductor itself. The side panel on the left gives launch points into various functional areas and stays consistent through the whole user experience. Next, let's go to the topology page. Unlike other SD-WAN solutions that require specific fixed WAN topologies and only work with bookends like hub and spoke, SSRs can form highly flexible and diverse topologies. For example, in this deployment we have routers sprinkled across the globe. Zooming in on a hub site, you can see lines representing connectivity to branches as spokes. This hub is labeled as HA because it operates as a logical router with multiple devices for redundancy. Also worth noting, the colors of these routers have meaning. For example, the hub icon is colored blue, indicating it is healthy. The orange color of the branch router here means that they are currently in maintenance mode, thus suppressing any associated alarms. Panning over to the West Coast, in Seattle we have a branch router forming a mesh with all other US branch routers. This same WAN interface that acts as a spoke to the hub is also meshed with WAN interfaces of these other branches. Now, let's take a look at this branch router in Seattle. On the main router page, you get an at-a-glance overview of traffic and health. We can see a snapshot of current sessions and bandwidth information. Our Seattle branch router is running the 5.1.0 software version with 4 configured network interfaces. Next, we have our node. A node is simply a physical or virtual device powering the logical router. This branch is operating with a single node. It is possible to have multiple nodes clustered together to form the router, such as the HA hub we looked at previously. The current status of node resources are seen here, including CPU cores for control and management functions, as well as a single core dedicated to packet forwarding. This CPU core allocation is typical for small to medium branches, but can be increased for higher performance at larger sites. Our node has been up for 4 days, and from a lifecycle management perspective, the asset is in a running steady state. To give some examples of other asset states a node could be in, you may have things like stopped, starting, or upgrading. An overview of the Layer 3 network interfaces shows up-down status. They are all up in this case. It also shows static or dynamic IP addresses associated with each network interface. In this configuration, they are all statically configured. The physical Layer 2 device interfaces are also shown, along with their up-down status and associated MAC addresses. You can also see this node is not using interface redundancy as it is standalone. Moving to the bottom of the page, you can see the other SSRs that this router is paired with. SSRs form a topology with one another based on layer 3 IP reachability, giving them potential next hops for routing sessions. As they are made aware of other peers' reachability from an interface, they begin to monitor path reachability and performance. Here we see discovered properties of the path, including latency, packet loss, jitter, MOS, and MTU. We can also use this to control the process lifecycle of the SSR node. For tasks where a command line interface is handy, or for those who prefer CLI, a remote CLI session can be launched from the conductor. The CLI offers a text-based interface with near feature parity to the GUI. For example, let's look at the same system status information that was presented in the GUI. Next, let's look at the device interface status on the node. For those familiar with Linux, a traditional shell to the system is available as well, where you have many of your favorite Linux tools at your disposal. Heading back to the router page in the GUI, let's look into the traffic the SSR is seeing. Using DPI-based application identification methods, you can see a variety of domains for which sessions have targeted. Here we have some sessions going to ESPN, CNN, Juniper, and others. So let's look deeper at the top sessions consuming bandwidth right now. At the top, we have a graph of total bandwidth for the router plotted over time. In the table below, we have the current top bandwidth consuming sessions. Clicking in on an individual session, you get the most detail from the SSR. You can see things like session type, the service class for quality of service, and the security policy applied to the session. You can see that this particular session is being sent to the Boston data center peer, and the TCP state is established. All the details for when you need to look at a session under the microscope. Best of all, you can click to different points of time in the bandwidth graph when you see something interesting, and the table below updates for top sessions for that point of time you have selected. Every session you see on the SSR is ultimately going to be destined for a service that is important to your business. Here we see some of the analytics that are devoted to our corporate internet service. Services group one or more applications into a named service that is distributed to the routers managed by the conductor. All destinations described by the service can be given their own routes and policy for things like path selection, security, access control, and SLA. For example, here you can see the multiple different paths that make up the route for the corporate internet service. At the bottom, you have the security policy that will be applied, and the service policy, which will prescribe how routers will treat sessions based on service level agreements, load balancing, and quality of service. Services may represent many applications in a large network block, such as our corporate internet service, or LAN prefixes in a branch or data center. They can also describe individual applications like SaaS or custom apps in a data center or private cloud. Heading over to the services page, we can see some of the other services that have been named and given discrete policies. Who exactly can access these services are shown here. Network devices are segmented into logical groupings called tenants, and all devices belonging to that same tenant will have the same level of access to services. Here you can see devices segmented into tenants such as engineering, finance, sales, and guest, and we can easily inspect the services any particular group of devices can access. Throughout the conductor so far, we have seen how metrics, statistics, and analytics provide deep insights depending on the functional area you are looking at. But how about when we want to customize? The SSR provides thousands of different metrics and analytics, and it can all be viewed in customizable dashboards. For starters, the conductor provides many built-in managed reports, such as the SVR comparison tool. This calculates annualized total savings of the SSR's tunnel-free technology versus other tunnel-based SD-WAN solutions. This analyzes traffic data from all managed routers and compares the data overhead of SVR to the tunnel overhead from typical SD-WAN. For this deployment, the tool projects over 2 terabits of data will be eliminated by going tunnel-free, eliminating congestion and saving available bandwidth for the best possible user experience. An alternative comparison is available for contrasting the savings against DM VPN solutions as well. For detailed explanations of the calculations behind the numbers, you can check out the help text or go to the product documentation. Another built-in report shows data collected from monitoring all available peer paths on a given SSR. For this router, the latency on paths to its peers is low, and no loss has been measured in the past 30 minutes. You can expand the time window to show data from farther back in time as well. Going back 2 days, small fluctuations are seen, but no major abnormalities. You can select a specific data series at the bottom of any graph to filter out other plotted lines. Now, let's use this report as a basis for a new custom report. After giving it a name, we can now fully customize the report. Here, we resize and rearrange the layouts of the charts. You can also create reports from scratch by selecting a new empty report. Let's make one showing MOS score or mean opinion score and values over time observed for peer paths of a router. These are just a few of the thousands of analytics collected by the Session Smart routers throughout their lifecycle. Speaking of lifecycle, the conductor also plays a key role in managing the software lifecycle of each router in the deployment. Going to the routers page on the left panel, you get a listing of all routers managed by the conductor. From here, you can check for the availability of new software. In this example, you will find updates are indeed available. Selecting a specific version, it shows routers that can download the new version before upgrading. You can also see routers that have already downloaded and are ready to upgrade. You can select individual routers to download or upgrade, or you can select from a handful of bulk operations. Once the selection is made, simply click Start, and the conductor will orchestrate the task. As you've seen, those are some of the highlights of key functions and workflows in a typical deployment of Session Smart networks. As Session Smart routers are placed across the WAN, from client to cloud, the conductor centralizes and simplifies many operational tasks for routers in deployments both large and small. Thanks again for watching.
Hello all, hope this really put you in the driver's seat of a typical Session Smart network deployment. We do have a couple of other demonstrations we'll go through here as well. Session Smart networks make up some of the largest SD-WAN deployments on the planet today. For example, networks consisting of tens of thousands of sites with rollouts of up to 100 routers per night are actively ongoing right now. The only way to accomplish scale to this degree is to drive consistency through automation. The key area here is to avoid snowflakes by rubber stamping these deployments. So the next demonstration is a pretty slick tool that we'll show you built into the conductor. It's this notion of native templating engine to ensure consistency and scalability for zero trust provisioning functions. So with that, let's just take a deeper dive into the templating engine. So in that same deployment where the demo video was taken, we'll log in and we'll look at the configuration. So the configuration of the conductor is that single pane of glass managing everything to do with services and routers that we previously discussed. So here you can see in the router page, there's currently 31 routers configured, and you can click, and in a kind of a lab or test environment, you can manually add these as well, onesie twosies. But when you really need to scale is where the templating engine shines. So if we click on the templating button here, there's 2 templates built in. The second one here is what we call our staging branch template. So this is created with the basic mode. So if we actually look into this template, we took our golden image and create a snapshot of this template. And then what we're going to do is we can start to create instances. So you can add as many instances as you like. In our case, we're just going to create a single instance here. We're going to call that staging branch 12. We will save that, and then we will go ahead and generate the config required for this template. So as we go, what we'll do now is go back to the configuration page, and looking in the conductor, we can see there are changes right within this state that are ready to be committed. So let's go ahead and commit those. So that's it. That's simple from the basic config templating engine. We can go here and now we can look at the we're now active running staging branch 12. So another example here is what I want to show you guys next is really more about the advanced logic. So let's just go ahead and look at the next one called add branch router. And if we look here, this is where we toggle this into advanced mode. And there's a couple pretty slick features here. Not only are we pre-populating variables, so this was done all via a third-party OSS BSS API call to populate variables, which you'll see in a second what that looks like. We're also defining schema, which allows us to define more custom variables and provide input validation on those variables. For instance, when we go back and we look at, we'll add a branch router, here you can see we've got an array of predefined values that we can define for the site type. These are free-form fields. And then a lot of what is in the config is we're concatenating a lot of these strings to form, say, our router name and whatnot. So in this example, we have inputs for 6 different routers created. And what we're going to do, just like in the basic mode, is we're going to generate that configuration template. Again, going back to the configuration page, we're going to see 6 new routers sitting here. And if we commit those, all of a sudden, that's it. Those routers that are all generated from API calls from a third-party OSS BSS tool on inputs from a provisioner are now in and live in your conductor. So now you say, well, what do we do next, right? So what we do next is part of the overall ZTP process. So we're going to pick on this notion of Houston branch. So Houston branch, if we go back and look at our router pages, and we can filter this down towards Houston, we are currently disconnected. So it's a very, very simple process. If we go into the branch itself and we go look at the node, think of the node again as that system that corresponds to the logical router of the branch. That branch is actually out shipped and ready to be added to our config. So we've got an ID that we match, and this ID does a couple of things for us. Most notably, it creates, this is the authentication method for the operator. So we're actually going to create that ID as Houston branch. We'll validate and commit, and then we'll go back to our routers page again. And if we, using the same, if we go to Houston, what we're going to see is that branch. Oh, you actually saw the provisioner. So that's our state. So this is the DevOps tools behind the scenes that's checking in this router. It went from key accepted. So that's the key exchange for encrypted traffic to be shared between the conductor and the router into connected. And in a couple of minutes, I won't bore you with the details, but a couple of minutes, this router will be running and able to take traffic. So hopefully that gives you a quick snapshot on just the simplicity of the notion of router templates and how we're able to ZTP routers online and put them into production in a matter of minutes. So far we've spent a lot of time discussing day 2 operational support. But what about when packets meet the wire? There are numerous features that make the SSR stand alone from other SD-WAN solutions in terms of performance, functionality, and preservation of user experience. For example, let's look at the online voice and video real-time communication experience between, say, a customer service rep and their customers. Really, it's all about ensuring this experience across IP networks is what Session Smart Router specializes in. And today we'll be going to look at this third demonstration on seeing this in action. So on the left here is an employee at the enterprise branch. So really, it's the basic multipath WAN scenario with an enterprise and an employee at the enterprise on the left. The branch is connected to a data center here with two separate links. The enterprise uses Zoom conferencing services, and the employee at the branch is about to join a video conference. So for this enterprise, Zoom is a business critical application. Accordingly, it is configured as a service in the network fabric and given a service policy, which makes optimal use of available connectivity. The service policy gives a service level agreement specifying a maximum allowable latency of 100 milliseconds. Also, the network paths are ordered in priority here, with the dedicated WAN failing over to the internet. So next, with the table set here, next what we're going to do is see what happens when that SLA fails to be met on a real-time Zoom call achieving sub-second failover. So for this demo, we'll join a Zoom meeting, meeting ID password. We've all lived in this world for a while now. I'm admitted in, and once I'm part of the meeting, the video streaming is going here. Note the excellent user experience, and we brought Kevin back. So thanks for coming back to us, Kevin. Next, going to the conductor here. This is where we're going to start to go into these Zoom-specific service analytics. So in this case, custom charts have been created to see bandwidth and latency for our Zoom application. So on this first chart here, you can see bandwidth is indeed using that primary WAN path, but not the backup internet path. Bandwidth on the internet path would show a different color. So the next chart shows the latency across each path with these values below the SLA threshold defined in that already created policy. So note the video is still active, user experience is still great, right? So now what we want to do is show how session failover works and the power of this tool. So what we're going to do now is introduce a networking tool where we'll inject latency on the primary WAN path. So here we're injecting 60 milliseconds of latency, which will create a round trip latency of 120 milliseconds. If you recall, this will exceed that SLA-based latency for the service. So that's done. Note there's no impact to the overall user experience. Kevin's user experience still looks great here. And next, to prove that latency is indeed higher, we'll go back and look at those same custom charts. So here you can see that the bandwidth is indeed moved. You can also see the latency is recalculated based on that networking tool. So again, we can kind of zoom in, and this is the power of analytics where we can zoom in on particular time periods, and you can zoom in and see exactly when that failover happened and where the 2 points crossed. And now we're actively running on that secondary path. So the scenario shown is an all too familiar user story. You're on a very important video conference call. A subtle network disruption causes the experience to be poor and the time to be unproductive. Only this time was different. The network was indeed session smart. It is oriented around the service, not the network. That's the key, right? It's this notion of the Zoom service that we defined. The Zoom application was giving a very simple network-wide policy, and the SSRs were constantly aware of network conditions, ready to react the instant that they changed. Then, when there's a subtle change in latency, not a complete network outage, or not a major event, but just a simple brownout, in this case, an introduction of latency, the experience was flawlessly maintained. So I hope you enjoyed these demonstrations highlighting really many of the key functions that make the Session Smart Network provided by Juniper truly a game changer in the SD-WAN space.
So Adam, you got to show off. Obviously, Adam leads our deployments. He's hands deep, neck deep in so many customer design sessions, architecture sessions. You know, really helping put this into the hands of customers. That's what he's busy doing all day. Um, I wanted to kind of jump in here and steal back a little bit some thunder to some of the stuff that I'm working on in my product role. And of course, that is Mist. You know, no doubt by now. First of all, are you guys able to see my screen? There we go. I see it.
Yep.
Yeah, so no doubt by now you've participated in a number of the other boot camps, and you know you've seen this suite of assurances that that the team over at Mist has been busily taking to market. Now, what you see here are Session Smart routers in the Mist cloud. So if we go into some of these, you'll see familiar, for those of you that are familiar with Mist and know what it's all about, you can see now you have Session Smart routers and insights and analytics built right into the Mist cloud. So this is really just a sneak peek at some of the exciting stuff that's in the works coming soon for Mist WAN assurance. Session Smart routers are coming to Mist. And you know, we've talked a lot at this point about how you know the mission we were on, that the Session Smart router was on prior to Mist. You know, while we have kind of been busy instrumenting the data plane for service awareness and incredible visibility, the folks of Mist have been building, you know, this engine to consume that data, correlate it, analyze it, highlight anomalies, isolate root causes, all at cloud scale. So you know, if hopefully you got a chance to sit through some of the assurance sessions that were previous, but you know, the whole point of assurance is assuring that experience is good, and you know, for those that have been deeply involved to date in the selling and deploying of Session Smart routers, you know, no doubt everybody just loves all the data and insights that the Session Smart routers give them. But I know someone that loves it even more, and that's Marvis. Marvis has been busily consuming data, creating models based on network data for years, and that's why in many ways it feels like we have been sort of skating to the same puck. Again, the Session Smart routers really from the wire down and Mist from the wire up and Mist from the cloud down. So, you know, we're really excited about Session Smart routing coming to a Mist portal soon. And I know Tim's going to touch more on the experience-based networking, why it matters in the next session. So that concludes these set of demos. You know, it's been great to talk with you guys today. I'll be active in chat, and let me kick it back over to Kenny.
Fantastic. Thank you, gentlemen. You know, really exciting stuff. Really love to see the progression of the solution since the early days. I wondered, you know, Reed, I know you have a busy schedule. Do you have some availability to take a couple of questions here?
Sure. That'd be great.
You know, can you just give, you know, the audience a little bit more of an idea of the specifics around how latency loss and jitter is measured, you know, within this technology?
Yeah, great question. Great question. Actually, a variety of ways. You know, that latency loss and jitter that you saw in some of those charts. You know, we're really on our second version of methods that we use to detect and analyze that sort of thing. Historically, the primary method was using a protocol called BFD. Like I mentioned, as these Session Smart routers kind of drop into the network, their interfaces, you know, every router has a layer 3 interface that goes on to a network. That's what makes it a router. And it uses those networks as waypoints. And, you know, again, traditional solutions may try to stand up tunnels with this. With Session Smart routers, they just see each other's waypoints and begin to monitor them. They'll start to kind of probe out with BFD and use that to monitor the loss, latency, and jitter between their peers and the availability of that peer ultimately as a potential target for a session. Now, the second method that that has just been introduced in our recent version of software actually, goes a step further with that. And when we have active sessions being forwarded between those two waypoints, we will start to actually mark. Tim's gonna. I don't want to steal. I keep wanting to steal Tim's thunder. Tim's going to talk about metadata, but we will mark and kind of color select numbers of packets going on between those waypoints, and we will do so across different service classes. So those that are familiar with having like a big diff serve domain or a network that has quality of service throughout, they will know that every service class can operate like a totally different network. I mean, your high service class can look like one thing from a loss, latency, jitter perspective, and your lowest service class can look completely different. So now by sort of marking these packets in band, we get a complete view of loss, latency, jitter across the service classes. And again, we feed that back into our routing, our smart routing algorithms. And so, when a session arrives that we need to route on a path, and if there's an SLA, like Adam described, you may have a scenario where the high service class is looking good, everything's great, you're below SLA, but this particular service needs to go in a best effort service class and it's not meeting SLA. And of course, that's all detected using these mechanisms. So it's a combination of kind of out of band with BFD and in band with this kind of marking or coloring of selections of packets between waypoints. Great question.
I think you stole all my thunder, Reed. Great answer. But the only thing I would add to that is those are all highly tunable. So when we get in field deployments, your MPLS links versus say your LT links, you want different sets if you're passively monitoring that and gathering link quality statistics. You definitely want different intervals of that versus a metered and unmetered connection. And we have best practices around that. And everything that Reed talked about is very highly tunable with best practices.
Definitely. Great question. Are there any other questions, Kenny?
I think there are, and it's okay to steal people's thunder. I mean, that's the advantage of going first, here, right? Take all the thunder you can get. I think, yeah. So two questions here. We've got a couple of minutes here before we're going to go to a break. For the peer paths shown in the demo, how is the topology formed, and then what additional topologies do you support?
Adam, you want to take that one?
So I, the demo, if you remember the first part of that demo, there's a notion of branches and data centers, and the branch really is the primary function is in a spoke to the hub to the data center. Now, how we tie all that together is a really, really simple piece of config logic, and that we give things a label. So we give them a label. We call it a neighborhood in our data model, but simply it's just a label. So you give a label on both sides, and then you put it in this role. And then once you put it in the role, you've got IP reachability, and will automatically peer up, so we can start exchanging SVR. So the difference here is it's really you're defining that underlay, so you can start to send sessions over based on this label. And the other thing worth noting is when you create these labels, it's really, really flexible. So I can have the same WAN interface operate as maybe a spoke to my data center hub, and then in that demo example, it's also operating as a mesh to all the other regional branches on that same network interface. So a really, really flexible topology model, again, just to drive topology of what can talk to what based on IP reachability.
Yeah, and I like to think of those neighborhoods. I mean, they're called neighborhoods literally to think of them like topology, like Google Maps. Think of neighborhoods in a cul-de-sac or something like that. When you declare two interfaces of two SSRs out there, to be in the same neighborhood, you're sort of declaring that they can reach each other potentially, and you define any one interface's role in that neighborhood, spoke, mesh, hub, and based on other SSRs that are in that neighborhood, it'll reach out and start to see if there's a path to the other ones. Great question.
So when it comes to the cloud, what is the deployment model connecting to the cloud? If the cloud is managed by a separate, well, I'll say this: when it comes to SSR in the cloud, can you use SSR to connect to the cloud, and can you expound upon that a little bit?
Well, what is the cloud if not for somebody else's data center? But but yes, the quick answer is yes. We that's a very common use case, connecting various sites to various clouds. Even connecting clouds together is a popular use case, and there's really a variety of methods that we use to go about that. Obviously, you can actually have an SSR router running right there in your cloud instances, kind of providing gateway into your various VNets, or they all have their own terms for it, VNets, or I forget what AWS, or anyways, they have their own, but basically your networks where your cloud workloads are sitting on, and that's one way. We also integrate with things like Azure Express Route, for example, to kind of provide routing into the cloud environments that way. So and Azure Virtual WAN is another one that we connect to. There's also security clouds like Zscaler that we support connections to, and again, by standing up a target, whether it's an IPsec tunnel to a Zscaler security cloud, or you have a Session Smart router at the edge of your of a various cloud region, ultimately you can just install a service there, and the whole fabric figures out how it needs to get there, how to get there, and how it needs to treat it.